Hi, this video is on the law of sines. So first of all, let's see how this particular law can be derived. If we take any triangle, then we can draw a height, which we're going to label h. Let's label it h1 because I'm going to need another one. So from this triangle here, we can say that h1 is b times sine angle A from this triangle. The hypotenuse times this angle will give you the opposite. And then if we express the h1 from the other triangle, from this triangle here, then h2 is going to be A times sine B. And because it's h1. Because the height is obviously the same, then these two expressions are going to equal each other. So we have A sine B equals B times sine A. And you can rewrite that as A over sine A equals B over sine B. Okay? So if I take the same triangle and draw another height from a different vertex, let's see here, and I'm going to label that as h2. So in this triangle, in this large triangle, if I take this triangle here, then I can write that h2 is going to equal A times sine C. From this triangle here, I can write that h2 equals C times sine A. Then obviously again these two things are the same, so these two things are equal to each other, so A times sine C equals C times sine A. And then you can say that A over sine A equals C over sine C. Okay? And then you actually have two things that are the same here, A over sine A, and then all three things are equal. So here is a law of sines right here. Let's just clarify one thing, that when we use this, the way it's labeled is always going to be that angle A is always opposite of side A, lowercase a, angle C is opposite side C, and angle B is opposite sine B. So this is law of sines that will allow you to solve any triangle, and by solving a triangle we mean that we're going to be able to find the measures of all three sides and all three angles. Some of this information obviously is going to be provided so that you can do it, but that's what you're going to be able to do. So triangle is no longer going to need to be a right triangle to do that. To be able to use law of sines, you do need to have the measure of one side and the opposite angle, and then you're going to need another side or another angle. So let's go ahead and take a look. So this is our first example. We have this triangle here, triangle ABC. We know A is 15. So we can write it here. This is 15. Angle A is 34 degrees, and angle C is going to be 80 degrees. So what can we write? When we actually use the law of sines, we don't need to write all three. We usually take two of those ratios. This is called an extended ratio, so we typically take like this part, or take this one out, or take this one out, and just make two of them equal to each other. Alright, so what can we do? First of all, we can find that since two angles are given to us, we can already find that the measure of angle B is going to be 66 degrees. All three angles will have to add up to 180, so that's pretty easy. Okay, then we still need to find the two remaining sides. So what can we do? We can write that this side over the sine of that angle, so it's A over sine A, is going to equal this side over this angle, which we already know. So it's going to be B over sine 66 degrees. So what can we figure out from here? We can figure out, it's pretty easy to do by solving this proportion, that b is going to equal 15 times sine 66 degrees over sine 34 degrees. And we can plug it in the calculator. Make sure your calculator is in degree mode. Don't use that in radian mode because it will not give you the right answers, and the answer is going to be 24.51 approximately. We're going to be rounding to 2 decimal places. So we still need to, so what do we have? We have all three angles. We know A, we now know B, we still need to find C. So let's write another statement. So A, which is 15, over sine A, which is 34 degrees, is going to equal C over sine C, which is sine 80 degrees. So from here again, we can write that C equals 15 sine 80 degrees divided by sine 34 degrees. And when you put it in a calculator, it's going to give you approximately 26.42 units. Okay, so we're done. We know all the measures of all three angles, and we know the measures of all three sides. Take a look at another example. So in this example, we're given the measure of side C, which is 43, the measure of angle C, which is 88. We are required to have an angle on the opposite side, and we know the measure of angle B is 43. Okay. So again, just like the previous problem, we can find that the measure of angle A is going to be 49 degrees. Okay. And then we write our statements. So we're going to be definitely using this C over sine C. So it's 43 divided by sine 88 degrees equals, and now we're going to be, let's try to find the measure of side A. So it's going to be A, which we're trying to find, divided by sine A, which is sine 49 degrees. So from this statement, we can write that A is going to equal 43 sine 49 degrees divided by sine 88 degrees. And your calculator will tell you that this is approximately 32.47 if we round to 2 decimal places. Alright? And we still need to find the length of B. So we're going to write again 43 over sine 88 degrees equals B over sine B, which is going to be sine 43 degrees. So from here, we can figure out that B is going to equal 43 times sine 43 degrees. It just happens so that they're the same numbers, divided by sine 88 degrees. And this will give us approximately 29.34. Again, please make sure your calculator is in degree mode. Lots of mistakes can happen when you use it in radian mode, and sometimes you can even get weird answers like negative values. Okay, or values that don't even make any logical sense. Alright, let's go ahead and move on to example 3. So we have this triangle. In this triangle we have this side as 103. Measure of angle C is 94 degrees. Measure of angle B is 31 degrees. Okay, so we can figure out that the remaining angle, angle A, its measure is going to be 55 degrees. So we know all three angles. Now we can find the side. So we know a side and the opposite angle are right here, 103 and 94 degrees. So we're going to use that, 103, let me rewrite that, 103 divided by sine 94 degrees equals, now let's find side A first. So side A is right here. So A divided by sine A, which is sine 55 degrees. So from this we can write that A equals 103 times sine 55 degrees divided by sine 94 degrees, and it's going to equal approximately 84.58. if we round to decimal places. And then we need to find the measure of side B. So again, 103 over sine 94 equals B divided by sine 31 degrees. From there we can conclude that B is going to equal 103 times sine 31 degrees divided by sine 94 degrees, and that's approximately 53.18. One other thing that I wanted to mention here, remember that in any triangle, the longest side is going to lie across the largest angle. It's always going to be opposite the largest angle. The shortest side will always be opposite the smallest angle. So if you look at this, let's see, we have, this is our side B, right? This is our side C. So with our smallest angle here is B, and our shortest side is going to be 53.18. Our longest side is 103, largest angle is 94, and our longest side is 103. It's always a good way for you to check to see if your answers make sense. Alright, how about this situation? So what we have here is a triangle like that, and we're given this information. So the measure of angle A is 37 degrees, side A is 15, and side B, so side B is this one, opposite angle B is 21. Again, remember, this is side B, this is side A, this is side C. We always label them opposite of their respective angles. So we only have one angle here, and but we have an angle on the opposite side, so we can go ahead and do that. So we're using 15 divided by sine 37 degrees equals, and then let's go ahead and find, try to find angle B. So we can do 21, which is side B, divided by sine B. So from here, by doing simple math, you can figure out that sine of angle B is going to be 21 times sine, excuse me, sine 37 degrees divided by 15. So you will get a value of sine. So if you actually do arc sine of this value here, this way you can just plug it all, the whole thing in the calculator, and you will get that the angle B is approximately 57.41 degrees. Okay, so to find the measure of angle C, you can do 180 minus 37 minus 57.41, which will give you that this is this angle is going to be 85.59. There's maybe a slight rounding issue here. Just be aware of that, the more digits you're going to leave here, the more accurate all the other numbers are going to be. So now from this, now that we know angle C, we can write that 15 divided by sine 37, which is A over sine A, equals side C, which we're trying to find, divided by sine of 85.59 degrees. And from here we can write that C is going to equal 15 times sine 85.59 degrees divided by sine 37 degrees. And the calculator will tell you that this is going to be approximately 24.85. So we found all our dimensions. But here is a problem. If you look at this triangle, this is fixed, this is fixed. This side's not fixed, this side is also fixed, but this side can also go like that. Let me show you what I mean. This is what we call the ambiguous case, because this is how we decided that our side A was going. But there's also another possibility, it can go like this, because this can still be 37 degrees. This side here can still be 21, and this here can still be 15. But this is an obtuse triangle. And the problem here is that this is a case that does not have a unique solution. And you have to be aware of that, because when you have this ambiguous case, you have to be aware that you are going to get two possible solutions and you're going to have to find both of them. So how do you find the measure of this angle here, angle B, based on what we found in the other problem? Because you still need to do it the other way. So in the previous problem, we found that the measure of angle B was 57.41 degrees, right? So what we are going to do, the measure of angle B in this problem, it's pretty easy. You just do 180 minus that other value, and that's going to give you 122.59 degrees. So that's another possible triangle. So what does it mean? That means that your values for everything else are going to change. The only things that are going to be fixed is B, A, and angle A. All right. So we're going to go ahead and, we can find the measure of angle C now. So the measure of angle C is going to be 180 minus measure of angle A, which is 37, and minus the measure of angle B, which is 122.59, and that's going to be 20.41 degrees. Okay, so now we can go ahead and find the measure of side C. So 15 over sine 37, side A over sine of angle A equals C divided by sine 20.41 degrees. So C, side C, is going to be 15 sine 20.41 degrees divided by sine 37 degrees, and in this case side C comes out to be 8.69. So completely different values for all the other things except those that were given to us. All right, again, this is an ambiguous case. It happens, and you have to be aware of that. You have to consider different possibilities for triangles. All right. So what else do we need to know about law of sines? Law of sines can be extended to finding area of triangles. So here's what I want to show you. If I draw the height, how do we normally find the area of a triangle? We do 1/2 the base times height, right? The area of a triangle is going to be 1/2 base times height. But how can we find the height here? We can find the height as B times sine of angle A. We did this earlier when I was explaining how to derive the formula. Okay. So then according to this, you can write the area as 1/2. So for this setup, the base is C, and the height is going to be B times sine A. So we get the formula that the area of any triangle can be found as 1/2 times the product of two sides, B times C, times, this is actually the angle between them. We call this the included angle. In a similar fashion, you can write that the area is going to be 1/2 AB times sine C, or the area can be found as 1/2 times AC times sine B. You don't need to memorize them. It's actually pretty easy, because all you do is 1/2 times any two sides times the sine of the angle between them. Take a look. 1/2 times two sides, B and C, times the angle, the sine of the angle between them. 1/2 times the product of two sides, A and B, times the sine of the angle between them. It's this formula. Or 1/2 times the product of two sides, let's say A and C, times sine of the angle between them, which is this one. Okay, so this is how you can find area of a right triangle, but you do need to know two sides and the measures of two sides and the measure of the angle between them. And we're going to do a couple of examples. So in triangle ABC, A is 14, B is 17, the measure of angle C is 37. By standard description of triangles, A, B are going to be two sides, and then this angle is going to be opposite of side C, which is actually going to be the included angle here. So the area is going to be 1/2 times 14 times 17 times sine of the angle between them, which is sine 37, and it's going to be approximately 71.62. We have units here, so square centimeters. That's going to be the area of that triangle. Another problem here, quick example. Side B is 21 inches, side C is 15 inches, measure of angle A is 102. That's the angle that's between these two sides, the included angle. So to find the area, we're going to do 1/2 times one side times the other side times sine of the angle between them, which is 102 degrees. And when you put it all in the calculator, it's going to give you 154.06 square inches. Okay, this is how it's done.